Hello everyone, this is Mugabe Joshua from the Automotive and Power class. So I'm going to present to you example 3. So our example 3 is telling us to find the Laplace transform of a unit step function u of t minus a. But first of all, we have to understand and know what a heaviside function or a unit step function is. So like you're seeing right here, this is a unit step function, like we looked at it in the Fourier transforms. So our function is always 0 if our t is less than 0, and our function is always 1 if our t is greater or equal to 0. That's a unit step function. But so let's go into the solution. So our first step is to define the function. So this function we have been given u of t minus a is always 0 when t is less than a. But our function is always 1 when t is greater or equal to a. That is how we define this function, u of t minus a. So if we describe it graphically, from negative infinity to a point a, our function is 0. But then this function jumps to a height 1 or becomes 1 from a to positive infinity. That's how we describe it in a graph form. So this shows us that it is a very useful function. If you have any function that you think should have a discontinuity at a particular spot, when you multiply it by this u of t minus a, where a is the spot you want the discontinuity, it introduces a discontinuity. So this is a wonderful way to be able to model a lot of functions that have step discontinuities. You just multiply it by this heaviside function or the step function. Yeah. So, but we have to compute the Laplace transform of this function, u of t minus a. This is our step 3, finding the Laplace transform. So we know that our formula for finding the Laplace transform is this one, like you're seeing it. But we well know that our function is always 0 from negative infinity to a point a. So this one will just come to 0. But then it is 1 from a to positive infinity. So if you compute it and put in the limits a to infinity, we get our answer as the exponent of negative sa out of s. And that is our final answer. Thank you.